Kiddos, hope you're enjoying day 2 of Snow Day. What I wanted to do is, you guys asked, a couple of you sent me emails or texted me about questions from the assignment that I posted. So I would like to show you an example problem using AH. So remember, there are 3 conclusions of AH, altitude on hypotenuse. Okay? The first is that the altitude squared is equal to piece times piece. All right? The second is that this leg squared, is equal to the piece of the hypotenuse that hits it times the whole hypotenuse. And the third is kind of like the second, but for the other leg, is this square this leg. This leg squared is equal to that piece times the whole hypotenuse. Okay? So I'm just going to use each of those legs to solve for x, y, and z. Okay? So starting with x first, note that x is a leg. All right? So I'm going to use my leg squared. So leg squared equals really piece of the hypotenuse that hits it, times the whole hypotenuse. All right? So using that rule, I can create an equation that will help me solve for x. So x squared, x being the leg, therefore equals piece, the piece of the hypotenuse that hits that leg, which is 3, times the whole hypotenuse. Now the whole hypotenuse is, that's right, 12. All right? So that gives me x squared equals 36, which means when I take the square root of both sides, really I get x is equal to plus or minus 6, but because I'm talking about a length, I only need the positive 6 value. Okay? So there is the value for this leg using the leg squared as piece 3 times whole. Okay? I guess while I'm doing that same rule, I'll solve for z, z being the other leg. So z, the leg squared, z squared is equal to the product of the piece of the hypotenuse that hits it, which is 9, times the whole hypotenuse, which is 12. Okay? So if z squared equals 9 times 12, I want to solve for z, right? So I'm going to take the square root of both sides, or I can do this a number of ways. Why don't I multiply first? You don't have to, but I guess I will. So z squared is equal to 9 times 12. 9 times 12 is, what's that, 108? Okay, now I'm going to take the square root of both sides to get z is equal to, actually maybe I write this really plus or minus, but I'm going to ignore the minus because I'm talking about lengths here. So it's z equals plus or minus, but again, no minus, just plus the square root of 108. Now, 108, I need to find some square factors, right? And I'm pretty sure that, let's see, 9 times 36 goes into 108. In fact, it does. So z is equal to the square root of, I'm just going to clean it up now. I don't like leaving it any square factors in there. So 108 is equal to 36 times 3. Right, all into the square root, right? And so what happens is the square root of 36 comes out as 6, and in stays the 3. So I get 6 root 3. Okay? The final piece I can solve for y. Note that y is the altitude, right? So I'm going to use the altitude rule. The altitude rule says altitude squared is equal to the product of the 2 pieces. So I just call it piece times piece, right? Which 2 pieces? Well, the 2 pieces of the original hypotenuse. Right, so using that rule, y squared has to be equal to the altitude squared equals 3, one piece, times the other piece, which is 9. All right? And so now what I'm going to do is, in order to solve for y, I'm going to take the square root of both sides. Don't forget there's a plus or minus, but really for this problem there's not, because it doesn't make sense to have a negative length. But instead of multiplying it out and then cleaning it up, I'm just going to take the square root right away of both sides, because, well, you'll see why. I already have 3 times 9 and 9 is a square number. Right? So out comes the square root of 9, which is 3. In stays the other 3. Okay. So hopefully this helps, right? You can see how I'm using either leg squared equals piece times hypotenuse rule or the altitude squared equals piece times piece rule to solve for x, y, or z given this right triangle and the altitude to the hypotenuse and using AH, altitude and hypotenuse. All right, hope this helps. See you tomorrow. I want you to finish those problems that I sent the other day for class. Bye.